All right, lesson 21. We're looking at if then moves, integer cards. So remember, integer cards, number cards, we're talking about integer, which are things like they're whole numbers, right? They can include 0 and can be positive and negative. Could be either, okay? So I dealt myself 3 cards. I got a -2, a 2, and a 1. So what's my score? Well, it has to be a sum. Remember, sum is the answer to an addition problem. So I would add these two pieces, these 3 cards together. -2 plus +2 is 0. 0 plus 1 is 1. My score is 1. Woohoo! Okay, now as I look at my new score, what I'm going to look for is I'm going to be given 1 additional card here. And so I ended up getting, ironically, a 0. Did not change anything. It changed the equation in the sense that I added a +0 to it, but the actual answer, -2 plus +2 is 0, plus 1 is 1, plus 0 is still 1. So that's my score. If I were to then replace this with a +2, then my score would be, my new score would be a 3. If I were to instead replace this with a -2, then my not as pretty star, but new score would be, well, I'd have -2 plus +2 is 0, plus 1 is 1, plus -2 would be a -1. So my conclusion that I'm drawing here is, as I continue to get, if we're talking sum, positive numbers get bigger, and negative numbers, since where sum is adding, get the total smaller. Shouldn't be anything in brand new revelations, but it is just something that we want to be aware of if we're talking sum. Okay, so as we continue with this, I can continue to add more and more and more cards. And so what I really want to look at here is, if I start with a, I'm going to skip this part here for a minute, and I'm going to say I had a 2, then I had a -2, I had a +2, I had a 1, right? And so what happens then if I double that? Well, let's see, I would have another -2, another +2, and a 1. So I'd have all of these things added together, and then this would be added here. These would be added. I can also take each chunk, since it's just doubled and it's just an additional, right? I can also figure out that this answer we said earlier was 1, and this answer is the same exact thing, which would be 1. And if I added those two things together, I would come up with 2. Right? So I can also take the sum of each part. If it's 2 parts and they're identical, I can just add those 2 parts together. So that's the conclusion that I really want you to look at. If identical parts or chunks add each sum part to come up with like one total, right? So that's again what I'm looking at here. It's just looking at additional and new ways to be able to create these things, right? We're going to go ahead and skip event 4. It's the same thing, it's just a little bit more. And so we're going to do quite a bit more of that with this next table here that we're looking at. So what we're doing is we have 2 different hands from this game and a series of changes that occurred. Each one we're going to be completing. So starting with the original was a +1. This one went farther down, a -4 and a +2. So 1 plus -4 is -3, plus +2 is a -1. That's my result. So now I'm going to add 4. You see how these 3 things have stayed the same, and I'm just adding this additional 4. So I can take my original result and add 4 more. I don't have to start from the beginning. So in that case, I could do my original result of -1, I add 4 more, I'm back up to a positive 3. You'll notice now that these are all in the same order, and this next one says subtract 1, so I can just subtract it. That's the new piece. So I've got my original result of negative 1. I have, after my next result of add 4, I got a positive 3 for my total. So then I can subtract 1 from my prior result, so 3 minus 1 is 2, and so on. Now, here's where it gets a little trickier, because now what we're doing when it says multiply by 3, we're really multiplying the entire thing. So I've got 1 plus, and then a smaller set of parentheses, negative 4 plus 2 plus 4 minus 1, close parentheses. And what this is really saying is I would be distributing it if there were any like letters in there, so like any X's or anything like that. I would have to distribute to every single piece. Since I can do the math inside, remember using PEMDAS, right, or please excuse my dear Aunt Sally, I would do parentheses first, so I could actually do all of this first, which I have my answer from before, it's 2, right, and then take that and multiply it by the outside 3. If there was a letter here, so case in point, this first one's a 1, but if it was somehow an X, I would only be able to do some of this, like say this stuff inside, and combine all that, but then I'd still have to distribute the 3 to the X and the 3 to something else. It's not a letter, so that's why it's able to do it, but I just wanted to point that out. So 3 times 2, my total would be 6 here. And then this last one says divide by 2. So now what I'm doing is the same thing as before. 3 parentheses, 1 plus parentheses, negative 4, close parentheses, plus 2, plus 4, minus 1, close parentheses there. And then I'm going to take all of that, so now a brand new set of stuff, and divide the whole total by 2. We can also take our prior result and just divide by 2, so 6, which is all that stuff inside the bigger and smaller parentheses combined, and divide that by 2. 6 divided by 2 is 3. We can do the same thing here, just a little faster. So this one has a 0, 5, and a negative 6. When we do the result of that, we get a negative 1. When I add 4, all I'm going to do is copy everything else before and then add a 4 here, right? And then the next one will be to subtract a 1, so I'm just trying to like get a little ahead here. Plus 4 minus 1 before I get going. So I can also take my prior result and add 4 to it. That's a positive 3. I can take my prior result and subtract 1. That's a positive 2. I'm going to multiply this whole thing by 3. So now I've got a 3 in front, and then everything else parentheses inside. And then the last one is going to be the big one. 3 inside of parentheses, and then everything else inside of parentheses. And 2 big parentheses, one smaller one, which closes this smaller one, and then just to make it obvious, that bigger one closes this bigger one here. And you'll notice we can still take the same things as before. Multiply by 3, we still get 6. We still take that, divide by 2, which was my final result. I needed to write that, divide by 2. And we get 3. You'll notice how it still ends up being the same result, right? Even though we had different hands, the original was the same result as far as the amount. So then everything else that we did when we would add 4, subtract 1, multiply by 3, divide by 2, since we did it to each hand, it's kind of like the whatever you do to one side, do to the other concept. And the last one here says complete the table using the multiplication property of equality. So as we look at this is my original hand, right? 3 plus parentheses negative 5 equals, so the original result, 3 and negative 5, is a total of negative 2, right? Multiply each one of them by negative 3. So in this case, I would take that and multiply it by negative 3. Now we're multiplying. Remember, when we multiply, we can use nope, right? Negative, odd, positive, and even. There are little arrows up above, right? And so I count 2 negative symbols. 1, 2. 2 negative symbols is an even amount, so my answer should be positive. Now I can just do the math. 2 times 3 is 6. And if we were to look at this, so that's the original, and then the equivalent would be the same thing here. So if we multiply it by negative 3, what it's saying is negative 3 parentheses 3 plus smaller parentheses, -5, close parentheses, close second parentheses. And the other equivalent expression would be actually writing it out and distributing. So I'm going to just do that really quickly. I have a -3, and then I have a 3 plus -5, close parentheses that way. So when I distribute this out, you'll notice I get 3 times -3, which is -9, and then I get -3 times -5. Negative times a negative is a positive, right? Using nope to even. So that should be a positive 15. And when I find the difference between a -9 and a positive 15, it is in fact a 6, which is the same answer as here. So the whole point of this specific lesson is to make sure you understand distributive property. All that does is it's applying each thing to all parts of a problem. Speaking of problem, we're all done with classwork. You're on to problem set.